All right, so we are here at our Gordon 2 site. I can give you a quick overview of everything we've got going on in this area. So off to my right, kind of out of sight up there, I have another tipping bucket as well as a precipitation collector. Behind me up here we have our stream gauge. It's specifically called a V-notch weir, and you can see why. This is our V-notch here. And this enables us to get an accurate discharge method, and that's really what we're looking for. By putting the stream gauge in here, we're kind of controlling how the stream flows through here, so we can get a more accurate record of discharge throughout the course of the year. So up here, this is called a stilling well, and in here I have another one of those pressure transducers, which measures the pressure exerted on the instrument by the depth to water. At this point in the year, we're not seeing very much pressure exerted on that. We're at the time of year we're experiencing what's called base flow. In the Rocky Mountains, we are in a snowmelt dominated water system. So we have what's called a hydrograph, which measures discharge throughout the course of the year. So during the course of the year, at base flow, we're at our lowest point in the year. It's our lowest discharge. Kind of goes along in a pretty flat line for the most part, until we get up to spring, when we get that snowmelt coming in, and we get a large rising peak on what's called the hydrograph, and then we get one maximum peak usually. That's our peak discharge for the year, and then it will kind of fall off from there, and then we'll have peaks and valleys from there that are usually responses to precipitation events or snowmelt or something along those lines. We'll also experience what's called a diurnal variation, which is a day-to-day change. Especially during the springtime, we'll see an increase in discharge during the day, and then as we get to cooler temperatures and that snow stops melting, it will fall off again, and we'll get a lower discharge at night than we do during the course of the day. Something else we experience in the spring during that snowmelt runoff pulse is we get a large amount of sediment transport, which I'm standing on the sediment that was transported down here by the force of the water. When we first installed this stream gauge last year, the bottom of the stream channel is kind of down here, and all of this stuff was deposited here in the spring by the moving water. And as you can see right now, that much water doesn't look like it's enough to move a rock that big. So if you can imagine, in the springtime we have water coming up to about here, and there's enough velocity, or the water's moving fast enough to transport. So also at Gordon 2 we also have, this is a Sigma brand, not an ISCO brand, automated water sampler. And this is, again, so we can collect data without having to be out in the field all the time. There's 24 bottles in the bottom of here, as well as a little computer, and it collects water samples only once a day. We don't have it doing it on the 10-minute interval. We would never be able to process that many water samples, but this guy collects a water sample once a day, and we collect them once a week and bring them back to the lab for the same analysis we do to the groundwater and the surface water samples. So behind me again, this is another stilling well, and inside here there's a conductivity logger that I was downloading before, and this samples conductivity every 10 minutes normally, and right now it's going to help us do our salt conductivity discharge method. So what we're going to do there is inject a known quantity of table salt that's mixed with stream water, and we're going to inject it, as the standard is to do it 30 times the stream width upstream to ensure that we get all of that salt mixed with the stream water. So being as how we're in base flow and we don't have very much water moving through the system in general, we don't have to go very far upstream. So we'll probably inject right there, and we wait for all of that salt to get down below our conductivity logger, and then we'll take that data back to the lab and be able to calculate a discharge from it.